Okay, everybody, hello. We're going to study a little bit of math. We're going to do some exercises for sixth graders. Meanwhile, I'm eating, so maybe in some points you're gonna see me eating. I'm sorry, but it's time to eat for me. But meanwhile, we can work out on some exercises of mathematics. If you let me, I'm going to connect my pad so we can work out on these exercises. First, we're going to work out on a question of integers about addition and subtraction of integers. And as usual, meanwhile you understand how to add or subtract integers, a good idea is that you observe how these numbers can be represented on a number line. Now, you don't need to do the number line. It's not completely needed that you do the number line, but you can imagine the number line here. And just in this case, 3 minus 5, just remember that if you subtract the negative is equal to adding the positive, and if you add the negative is the same as subtracting the positive. So in this case, for example, that we have 3 minus negative 5, the appropriate operation you need to do is 3, and you need to add 5 to this 3. So I hope that you know how much is 3 plus 5 to get the answer. And in this case that I have minus 5 plus negative 7, so both options are the same, that is minus 5 plus negative 7 or minus 5 minus 7. In both cases, we have the same idea. So we can use the same rules. Now let's imagine the number line. I want that you imagine the number line. And if you put the number line, we can put that we have minus 5. I'm just imagining the number line. And then after the negative 5, I'm going to put negative 7. So what I need to know is how much is this distance from here to here. And this distance from here, that is 0, to this point, so it's going to be the addition of 5 and 7, that is 12. And as I'm going to the left, it's going to be negative 12. This is the way you can add these numbers. This is the way you can work out with integers. Imagine the number line. Imagine always how to do the number line to do it. So this is some idea. We're going to work on some questions about integers and operations. Let's do one of this. That it's when you need to complete information that appears. Look at that, it appears like a line over negative 9 and it's negative 4. So remember that when we have a fraction, the fraction is just a division. So we just need to perform a division. So in this case, it's asking me which number divided by negative 9 is negative 4. And if you remember the rules of multiplying or dividing integers, so it's going to be that a positive integer divided a negative integer is going to be negative. Therefore, this number here must be positive. So positive divided negative is going to be negative. Now the number is going to be 36, because if you divide 36 by 9, it's going to give you 4. But as one is positive and the other is negative, the answer is negative. So this is some kind of ideas that you can work out to observe what happened. Remember that when you multiply integers is different that what happened when you divide, when you add or subtract integers. Addition and subtraction doesn't follow rules like the same rules of multiplications. When you multiply a number, when you multiply an integer, it's different that when you divide, when you add integers. So you need to be careful. In addition of integers, my hint is to imagine the number line. In multiplication and division, my hint is to remember the rules to multiply and divide integers. I have many videos in my tube that shows how we can add, subtract, and multiply integers and how to understand the operation of integers. So this is my hint. When you operate integers, addition and subtraction, imagine the number line. Meanwhile, you identify the rules. I don't like to tell you the rules of adding integers. I prefer that you discover the rules of addition of integers. and use the number line to find out which are these rules. First question here about integers. Now let's see something about LCM and highest common factor. We're going to see how to apply LCM and highest common factor, how to apply them when we have different numbers. I'm going to use the ladder method to find the LCM and the highest common factor. There are more options, but I like to apply them especially when we have three numbers like these three. Let's say I want to know the highest common factor of these three numbers, 8, 12, and 20. So as I'm going to apply the ladder method, I'm going to change, or I'm going to rewrite these numbers in columns. So I'm going to put 8, 12, and 20 in columns. And now I'm going to start performing divisions using a ladder. So I'm going to divide by common factors first. So as I can see, the three numbers are divisible by 2. So I can divide by 2. I'm going to circle because it's a common factor. 8 divided by 2 is 4. 12 divided by 2 is going to be 6. 20 divided by 2 is going to be 10. Now observe that the three numbers that I have here, they are still divisible by 2. So I'm going to continue dividing by 2 and circle it. Maybe you tell me, Mr. Hugo, here is the thing. I find out that the three numbers are divisible by 4. Can I start dividing by 4? It's not what it's expected, because it's expected to put prime numbers, but you can use it because your goal is to find the highest common factor. So I'm going to divide by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 10 divided by 2 is 5. And observe that here I cannot divide by more factors. So I'm going to stop because I already circled when it's by 3. If there are numbers that I can divide by 2 or by two numbers, I must continue doing my ladder without circling because they are not common factors, and finish when everything is done. Now in this case I'm going to stop. I could continue dividing by 2, by 3, by 5, but I'm not gonna do it because I want to find the highest common factor. So as it says highest common and factor, look at that here. I have the common factors 2 and 2, but the highest must be the multiplication of these two. So it's going to be 2 times 2, and the highest common factor of 8, 12, and 20 is going to be 4. Now the least common multiple avoids the fact that I need to multiply again by common factors because I already find out common factors. So the least common multiple is just going to be the common factor times the other parts of the ladder. So I'm going to multiply 2 times 2, that I know that is 4, times 4, times 3, times 5. So now I just need to multiply all these numbers. The LCM is going to be, look at how I'm going to multiply. First 5 times 4, that is 20, and 4 times 3, that is 12. So 12 times 20, and 12 times 20 is going to be the LCM of 8, 12, and 20 is going to be 240. So in this way, I find out the least common multiple and the highest common factor of these two numbers. But what I'm doing here is just operate them in a way that we can work out using the ladder method. So I can work out both at the same time using the ladder method. This is why I like the ladder method. I like the ladder method because with the ladder method, I can find out least common multiple and highest common factor using only one structure of operations. There are other options to find out. However, I need to do like one step to do highest common factor, one step to do least common multiple. And if I want to do them together, it's better to use the ladder method. Let's see what else we have. Let's talk a little bit about divisibility rules. Divisibility rules are something that, in plain terms, I suggest you to memorize them. Let me see. Okay, I just received a message of one question that we're going to see in a minute. We're going to see in a minute this question 24. Okay. But meanwhile, let's see the divisibility rules. So let's say that we have the divisibility rules. These questions are just for you to remember the divisibility rules. Remember that if a number is even, means that it's divisible by 2. So in this case, this number is not even, not divisible by 2. This number is even, divisible by 2. This number is not even, divisible by 2. Now, when it's divisible by 3, you need to add the digits, and then the addition of the digits must be divisible by 3. For example, here 9 plus 3 is 12. 12 plus 5 is 17, so it's not divisible by 3. Remember that if you want to know if a number is divisible by 4, you need to test the last two digits and see if they are divisible by 2. In this case, it's 0, 2, not divisible by 4, so not divisible by 4. I know if a number is divisible by 5 if it ends in 5 or 0, like this one, so check. I know that a number is divisible by 6 if it's divisible by both 3 and 2. In this case, for example, this number is not divisible by 6. And a number is divisible by 10 if it ends at 0. So for example, this number is not divisible by 10. Now, there are other ways. For example, here, I need to use these digits 5, 4, 1, and 2 to write a 4-digit number that is divisible by 2, 3, 4, and 5. So I'm just going to choose one of these. Let's say that I want a number that is divisible by 4. So I just need to write these numbers 5, 4, 1, and 2 in a way that the last two digits are divisible by 4. For example, 5, 4, 1, and 2. This is divisible by 4 because the last digits are 12. That is divisible by 4. Or let's say that you put 5, 1, 2, 4. The last digits are divisible by 4. Okay, this is when you apply divisibility rules. What happened about the squares and cubic number roots? So remember that a square root is the inverse of squaring a number. So for example, in this case, I need to get the square root of 49. So I need, what is the number that I have to multiply by itself that gives me 49? In this case, it's 7, because 7 to the second power is 49. Usual mistake that people have that mix multiplying by 2 with squaring a number. Remember that if it's a small number, an index, this is a 2, means that you need to multiply the number by itself twice. Okay, so just remember this when you apply it. Now, I just need to, now I know that the square root of 49 is 7 because 7 squared is 49. And the square root of 64 is going to be 8 because if I take 8 to the second power, it's going to give me 64. So this is what happened when you use square and cubic roots. Now, what is the deal? I need to do 7 minus 8. So I'm not good in integers. I need to do my number line. So create the number line, put the 7, and then put the negative 8. Look at that. If this is the 0, so you need to, the answer of 7 minus 8 is this distance that is here, but it's a negative distance. So I need to know how much is, if this is 7, I need to know how much is this in a way that it's 8. So it's 1, right? So it's minus 1. So the answer is minus 1. Okay? This is how you can interpret operations with square and cubic numbers and roots and apply cubic roots. Let's see another question. Let's talk about algebraic expressions. I need to convert the following expressions into algebraic language. So remember that when you apply algebraic language, your goal, your idea is that you create or identify where are the operations. Okay, so for example, I'm going to do the last one that appears here, the E that appears here, that it says I need 34 less than twice a number. So I need to identify where are the operations. For example, here, this less than shows me an operation that it's a subtraction. And this twice shows me another operation that is multiplying by 2. So your goal now is to convert this into the appropriate expression. Now I need this. I know that this is a subtraction. I know that this is 2 times. And look at that, it says a number. So this is 2 times a number n, or x, or a. But less than means that I'm going to take this number and subtract it 34. So I'm going to take 2n minus 34. So this is how you can write expressions, identify, highlight the operation you're applying, and in this way you can rewrite the expression using any operation that you want. So this is another work of how to do your job with expressions. Now let's see more about algebraic expressions. Let's see how to apply, how to simplify some expressions. For example, I have this one, and when you have these expressions, you need to simplify them, but just identify like terms. So I have like terms here. Look at these 4t and this negative 6t. They have the same variable, that is t to the same power. So essentially what I got to do is 4t minus 6t minus 9 plus 7. Okay, I can rewrite, but rewrite the expressions using the signs, because this negative 6 should be moved completely, not like subtracting this one. Now I'm going from left to right. 4 minus 6 again. So imagine that you have 40 here, and then I'm going to take 60 here. So I need to know how much is this arrow that goes here. It goes to the left, and look at that. If I have 4 here and I need 6, I need to put 2t, 40, and 2t is gonna give me 60, but goes to the left, so it's negative. So I'm gonna get negative 2t, and these numbers minus 9 plus 7. So I'm going to put minus 9 plus 7. If I put minus 9 plus 7, the number that goes here is negative, and 7 to reach 9 is 2. So negative 2 minus 2. This is how you can apply like terms, and this is how you can simplify the like terms. What happens if you have this structure? This structure is just applying distributive property. It means that you need to multiply by each term, applying the distributive property. So I need to take 4 times 3w minus 4 times 2. So I'm going to multiply. 4 times 3 is 12w minus 4 times 2, it's 8. This is how you can apply distributive property in algebra. Just remember that when you multiply coefficients, you can just multiply them, but when you have to add, you need to add like terms. This is how you can work in algebra. What happens if they ask you to work out the value of an expression like this one that is here? Negative 3a plus b over 3. I need to work out when a is 8 and b is negative 6. So essentially what I need to do is to replace a by 8 and negative 6 and b by negative 6. But here is the catch, and you need to be careful. This is not 38. This, remember that in algebra, we don't put 3 times a. We put 3a. So it means that this is a multiplication. As this is a multiplication, essentially what I have to do is 3 times 8 plus, and instead of b I put negative 6 over 3. So I'm going to perform the operations. Negative 3 times 8 is negative 24. Negative 6 divided 3 is negative 2. And I just need to do minus 24 plus negative 2. So minus 24 minus 2. So I need to imagine again the number line, put this, observe that I'm going to the left, and as both have the same sign, I need to add these two, so it's going to be 26. So the answer of this operation is negative 26. This is how you can convert, or this is how you can evaluate or work out the value of an expression. When they tell you how much is one variable, you can know how much are the others. Let's see more questions that we have. Solving applying function machines. I'm going to work out the second question that is here. And remember that solving using function machines is just the usual way that you can solve an equation. Function machine helps you to know what are the inverse operations you need to apply to solve the equation correctly. So I'm going to construct the function machine. I'm going to show you how to solve it using the function machine. And then I'm going to show you the usual strategy to solve equations in a way that you can just apply it every time you need it. But the function machine is useful because if you identify the variable, then you identify what are the operations over the variable. In this case, it's x. So which operations are over the variable? -2. So I'm going to multiply by -2. So I already did this part. Now I'm going to add 1. So +1. And after that, I have the whole multiplication. Look at that, there's no multiplication sign here, but it means that there's a multiplication by 4. And this is gonna give me 20. Now, if I go backward, this is like the input and this is like the output of my function machine. Now, if I want to go out in the other direction, I just need to put 20. So now I'm going in the reverse direction. Inverse operation of multiplying by 4 is dividing by 4. So 20 divided by 4 is 6. Inverse operation of adding 1 is subtracting 1. So the inverse, the subtraction is going to be 5. 6 minus 1 is 5. And the inverse of multiplying by 2 is divided by -2. So the answer is going to be -5/2. Okay? +5 divided -2 is -5/2. Remember that this could be written as a mixed number. Look at that. 2 times 2 is 4. So it's 1 to 5. So it's going to be 2 wholes and 1/2. Okay? Because 2 times 2 is 4 plus 1 is 5. So -2 and 1/2. Or if you want it as a decimal, it's going to be 1/2 is 0.5, so -2.5. What happens if they ask you to put it as a percent? So I multiply this number, this decimal, by 100. So I move my decimal point to the right twice, and it's gonna give me -250%. So it depends on the representation that you need. Sometimes we need percent, sometimes we need a decimal, sometimes we need fractions, depending on the context that we do. Now let's see how to work out some problems using the Polya strategy. Polya strategy helps you a lot to be organized in your operations and how to do it. So we're going to work out on this strategy. First, I need to know the known and unknown. So I'm going to identify what is given. Look, what is given. This is what is given. Now I need to put them a name on what is given. So it says 3, but 3 means what? It says Carlos buys 3 notebooks. So you can say notebooks bought. Okay. And $2.40 of pens. $2.40 is going to be the cost because it's in dollars. This is number of notebooks. This is the cost of pens. And then he says he paid $9.90. So it means that this is the total cost. Find the cost of one notebook. So the unknown, I'm going to put N, is cost of one notebook. Now, after you identify these ideas, cost of the notebooks, after you know, now you need to create the equation. You need to think how we can get the equation from this. So look at that, we have the total cost. The total cost. And the total cost is going to be, of course, the cost of pens plus the cost of books, right? Or notebooks. But he bought 3 notebooks. So it means that the cost of notebooks is essentially 3 times the cost of one notebook. Okay, so I know that this is 3 times the cost of one notebook. And the cost of pens, I already know that is $2.40. $2.40. And I know that the operation is $9. The total cost is $9.90. So I already have my my equation to solve. Look at, I just use my logic. I just read the problem, and after I got known and unknown, I try to identify how to get the expression. So usually when it says total cost or something, it means that you need to add to find out the total cost, right? And by addition you can get the answer. Now I'm going to solve the equation. So as I'm working with function machines, I'm going to multiply by 3, add 2.40, and I'm gonna get 9.90. Mr. Hugo, I don't like function machines. I prefer to solve the equation in the usual way. So use the function machine to solve it in the usual way. Look at that, the function machine tells you that the first thing you need to do is the inverse of adding 2.40. So it means that 3n is equal 9.90 minus 2.40. Now let's remember how to add decimal, add or subtract decimals in a way that it's that it could be fast. Look, 9.90 minus 2.4. I can just identify, look at, wholes with wholes, decimals with decimals. Oh my God. Decimals with decimals. And then perform the operation. So 9 minus 2 is going to be 7. And 90 minus 40 is 50. So both have the same sign. So it's 7.50. This is 3n. Now, I already did this part. I add, so I apply the inverse operation, that is subtract. Now I need to do the inverse of multiplying by 3, that is dividing by 3. So what I need to do is 7.50 divided by 3. Now, remember that if you're going to divide by a decimal, you can, if it's decimal by whole, you can just divide them, avoiding the decimal, and remember to put the decimal places. So in this case, this number has 2 decimal places. So I just need to put 2 decimal places at the end. Or apply long division. But just when you pass by the decimal point, keep the decimal point. So this is the idea. 7 divided by 3. So it's not possible. 2 times 3 is 6. And to 7, I need 1. So 15 divided by 3, I can do it, is 5. And 0 divided by 3 is 0. So I got 2.50. So the cost of one notebook is going to be $2.50. This is the cost of one notebook. And this is how you can solve the equation using the POLIA strategy. Identify known and unknown, formulate the equation, try to add, try to put what to do, and then you can finish it. And this is how you can solve the equation if you don't like function machines. But function machine tells you and helps you to understand, because we're learning algebra, we're learning how to solve equations. Function machines are going to help you to identify what are the inverse operations and in which order you need to apply it. Now, let's go with the next question that we can work out today. Let's work out a little bit of rounding decimal numbers. Let's say that I have this problem. It says round the number 0.3088736 times 10 to the 4 power to 3 decimal places. Now, what is the strategy? First, I'm going to multiply, and it's 10 to the 4 power, so it means that I need to move the decimal point 4 times to the right. So 1, 2, 3, 4 here. So this number is 8.8736, right? And it says I need to round it to 3 decimal places. 3 decimal places. So I'm going to count my 3 decimal places. 1 decimal place, 2nd decimal place, 3rd decimal place. So I need to round it here. I'm going to look the next decimal place, the fourth. It's 5 or greater than 5, 6. So I need to add one decimal here. So 8.874. This is how you get your answer of rounding decimal places. Let's continue working with some ideas. I already talked a little bit how to work out. I want to do this exercise of multiplication of fractions. The idea of these multiplications, you can multiply fractions by multiplying 5 times 2 and 24 times 15 and then simplify the fraction. But we can also apply cross cancellation or cross simplification. I mean, what means? This 5 that is a numerator could be simplified by this 24 or by this 15. Look at that, this 5 and this 15 shares a common factor, 5. So I can divide both by 5. 5 divided by 5, 1. 15 divided by 5, 3. And now I can see these 2 here and this 24 here, so I can apply also cross simplification by dividing these 2 by 2, that gives me 1, and this 24 by 2, that gives me 12. So this is gonna give me that this operation, that could be 5 times 2, 24 times 15, multiply both and then simplify, just give me 1 over 12 times 3. 12 times 3 is 36, so I can do it faster. Cross simplification helps you to do that. What happens if you have a division? Let's do this one. What happens if you have a division? If you have a division, division is the inverse of the multiplication. So you can find out the inverse of this fraction, that is called the reciprocal. The inverse multiplicative of a fraction is calling the reciprocal, and multiply by the reciprocal. So what I'm going to do is put it 21 over 48 times the reciprocal of this fraction, that is 24 over 81. Now, using this strategy, now I can apply cross cancellation, cross simplification. Now, cross simplification doesn't mean you cannot divide this 21 with this 48 if they have a common factor. You can do it. You can simplify this 24 and this 81 as much as you can and then multiply them. Look at, I'm gonna try this strategy. For example, these two numbers, 48 and 21, both are divisible by 3. So I can divide by 3. 21 divided by 3 is 7. 48 divided by 3 is 4 divided by 3 is 1, but there is 1 left. 18 divided by 3 is 6. And look at that, I simplify these two. Now I can simplify 24 with 81. Of course, I can divide them both by 3 as well. If I divide by 3, 24 is going to give me 8. If I divide by 3, 81. 8 divided by 3 is 2. 2 times 3 is 6. 2, 8 is 2. 21. 21 divided by 3 is 7. Now, so I got, look at that, I just apply cross. I didn't apply cross cancellation. I just divide by common factors. Now I can continue dividing by common factors. For example, I can divide this 8 by 8 to give me 1. And here, 16 divided by 8 is going to give me 2. So I just got 7 over 2 times 27. 7 times 1, right? And 2 times 27, it's 7 over 54. And this is a simplified fraction. I'm pretty sure that it's simplifying because I apply cross cancellation, okay? This is how you can work out in this type of exercises that we have here. I just received a message to work out on this exercise 24, that it simplifies an expression below applying PEMDAS. We're going to apply PEMDAS here. And the idea is that you identify, my hint is to identify terms. What means a term? How do you know that you have a term? You identify that you have a term when you have additions and subtractions. So whatever you have between additions and subtractions is going to give you a term. Why I suggest you to use PEMDAS in this way? As PEMDAS says, the last part they're telling me that I did something wrong and it was -4 at some place. Okay, let's see if somebody found some mistake in some explanation, but let's see. Meanwhile, I see the situation. We see. Now we need to identify the terms. PEMDAS means that the last one is addition and subtraction. So identify the last option. Look at here, there is a subtraction. So I'm going to work out two terms. I'm going to work out this term and I'm going to work out this term. So I'm going to work out term 1 here in this column and work out term 2 in this column. And at the end, I just need to simplify them, right? This is what I'm going to do. They told me in the 15b it was -4. Let's see. Let's go back meanwhile I continue. 15b, the answer. The answer of the 20 in the function machine. Okay, let's see the function machine again. It says x times -2 plus 4. It means -4 here. That's the mistake. I didn't put the -4. Times -4 divided -4 is gonna give me -6. -6. Okay, let's correct it. Thank you so much for your comments. I really appreciate when Mr. Hugo made a mistake of signs. -4 -6 -6 -1. I mean, the strategy is correct, but I got here some mistake. 20 divided by -4. Actually, 20 divided by -4 is not -6. 20 divided by -4, I was thinking in 24, is -5. -5 minus 1 is -6. And -6 divided -2 is 3. Okay, thank you for your correction there. I really appreciate these corrections. Look at that. When the structure is clear, when you understand the structure, you can find out mistakes of people who are working on it. Okay? Now, thank you so much. I don't like when I made this type of mistakes, silly mistakes, but it happens. It happens. This is why I usually finish my exams like with plenty of time, and I take time to review again all these problems in my exams, because it's common that you made these mistakes. Okay, you're not like, sometimes we're not aware of a negative sign, sometimes we're not aware of what we're doing, so you need to review, especially when you present an exam, you need to review many times. So let's go back to this question. Let's say that here we have two numbers and I need to apply PEMDAS, and my hint is to separate them by terms, and now I need to work out each term. So in this term that is here, 3/4 plus high plus this parenthesis here, I need to do first the parenthesis. So I need to perform the operation 4 1/4 minus 3 1/5. But remember that if you operate mixed numbers, you can do wholes with wholes and fractions with fractions. So basically it's 4 minus 3 plus 1/4 minus 1/5. Okay, 4 minus 3 is gonna give me 1. And to add 1/4 and 1/5, I need to find out common denominator. So I need to multiply 4 times 5, amplify the fraction 1/4 by 5 and the fraction 1/5 by 4. So in this way, I'm gonna get 1 plus 5/20 minus 4/20. 5/20 minus 4/20 is 1/20. So this is 1 plus 1/20. Now, as I'm going to multiply this answer by 3/4, I need to convert this mixed number, 1 and 1/20, as a fraction. I need to put it as a fraction. So as I want to put it as a fraction, remember that 1, a whole number, I need to put it as a denominator 20. So a division that gives me 20. That is 20 over 20. So 20 over 20 plus 1 over 20, that is 21 over 20 times 3/4. This is what I have to do. Okay, now I can try to apply cross multiplication, cross simplification. So 3 with 4, not common factors. 21 and 20, no common factors. 3 with 20, no common factors. 21 and 4, no common factors. So I just need to multiply these two. 3 times 21 is 63 over 4 times 20 is 80. Minus, oh, okay, I'm not going to put minus yet. Now I already finished my term number 1. I already worked out term number 1. So now I'm going to work out term number 2. I'm going to do it here. And then, as it's a subtraction, I'm going to subtract it. So 3 over 10 divided 30%. Now the problem is that I need to put them in the same representation. So I'm going to convert 30% into fraction. 30% into fraction is the same as 30 over 100. Or if I divide by 10, it's going to be the same as 3 over 10. So what I got is 3 over 10 divided by 3 over 10, right? So in this case, I have a number divided by the same number, so the division is gonna give me 1. So as you can see, I need to I need to subtract 63 over 80 minus 1. This is what I have to do. Now I can do the same strategy that we follow to subtract the fraction and a whole, that is write 1 as a division over 80, that gives you 1. Or some people feel safer if they put 1 over 1 and apply common denominator. In this case, multiply by 80, multiply by 80. So what I got is 63 over 80 minus 80 over 80. So I have common denominator. I need to do 63 minus 80 to find the answer. So imagine that you have 63 positive, then you subtract 80 negative. So my answer is going to be this negative number that is here. That is the number that completes 63 to 80. So in this case, it's going to be 7 to 70, 17. So 17. 17. So this is negative 17 over 80. I don't need to divide it in a way that I got the fraction. Now, let's say if it says it's a simplified expression below, okay? But imagine that you need to put it as a decimal. As the denominator has an 8, my hint is that you multiply by 125. Why by 125? Because 125 times 8 is 1000. So 1000, and it has another 0, so it's going to be 10,000. And multiply 17 times 125. So I'm going to multiply here 125 times 17, 35. 7 times 2, it's 14, and 3, 17. 7 times 1, it's going to be 7, and 1, 8. 5, 12, 11, 1125. This is what it gives me. 125 times 17. Let's see if we can, if I'm going to test it using another strategy. 125 times 17 is 10 plus 7. So 120, 100, yes, there is something wrong immediately. 5, 12, maybe I'm doing something wrong here. 7 times 5, 35, 3 left, 7 times 2, 14, 3, 17, 7 times 1, 7, and 1, 8. Seems correct here, but it's not correct. Look, I'm going to multiply 125 times 10. It's going to be 1,250 plus 125 times 7. 7 times 5, 35. 7 times 2, 7 times 2, 17, and 14, and 3, 17. And 7 times 1, 7 plus 1 is 7 times 1 is 7 and 1 I'm sorry. Okay, so I need to add these two numbers, but this is what I did here. 5, 7 and 1, 7 and 5, 12, 1, 1,200. I'm sorry, I got one here. 2,125. Okay, now, my God, look at it. It took me more time to multiply two numbers than to do all the PEMDAS strategy. As you can see, sometimes you need to get a workout on multiplications, like I did just. Okay, I just multiply this, and as it's dividing by 10,000, I just need to move the decimal point as many times as the power of 10. So in this case, it's 4 times. 1, 2, 3, and 4. So my number is 0.2125 as a decimal. I want it as a percent, multiplied by 100. 1 and 2, 21.25%. This is the idea of this answer. This is the idea of how to multiply and simplify using PEMDAS. Separated by terms and work out each term to finish. Mr. Hugo, I can apply PEMDAS strictly, first parenthesis, then exponents, then multiplication, then divisions. Of course you can do it. You're gonna reach to the same answer. Now let's see how to calculate percents. I'm going to calculate work out the 25% of 20. In this case, remember that in this context, of means times, and 25%, so it means 0.25, the decimal, times 20. So you need to multiply this decimal times 20 to do it, or you can also convert this decimal into fraction. 0.25 as fraction is 1/4, so you can 1/4 of 20, or it means divide 20 by 4. The answer is going to be 5. Or if you multiply this to the 20 times 25, it's gonna give you 500, and 500 divided by 100, because it's 2 decimal places, is going to be 5. This is how you can operate by getting decimals. Oh my God, I was just putting this in a small way. Maybe you couldn't reach to this answer, to this step-by-step process, because I put my face too high. Okay, finally, what happens if you need to divide a number into a ratio? So if you need to divide a number into a ratio, remember that this is like using shares. So how many shares are in total? I'm going to divide this number in shares. So if it's in the ratio 3:5, it means that the number of shares are the addition, 8 shares. And I need to know how much costs one share. So to know how much it costs one share, I need to divide 7,640 divided 8. Apply long division, or whatever is the method you prefer to apply. 76 divided by 8 is 9. 9 times 8 is 72. 276 is 4. Now 44 divided by 8 is going to be 5. 5 times 8 is 40. To reach 40 is 4, and 40 divided by 8 is 5, 955. This is the cost of one share. But I need to divide it in the ratio 3:5. So I need to know the cost of 3 shares. That is just $955 times 3. And I need the cost of 5 shares. That is going to be 955 times 5. So I'm just going to multiply hello for the people who enters to this live session. So I'm just going to multiply this. This is going to be 9 times 5, 3 times 5, 15, 1 left, 3 times 5, 15, and 1, 16, 1. 3 times 9 is 27, and 1, 28. 2,865. 5 times 5, 25, 2. 5 times 5, 25, and 2, 27, 2. 5 times 9 is 45, and 2, 47. Okay, so this will be like the sharing. How can you test it? I'm going to add these two, and the addition of these two should give me 7,640. 5 and 5, 10. Good. 7 and 6, 13, and 1, 14. Good. 8 and 7, 15, and 1, 16. Good. 4 and 3, 7. It's correct. So my ratio is 2,865, and the other is 4,775. This is how you can share your work in 3. This is the idea. This is how you divide a ratio into a work. Now everybody, so I hope that everything is correct. Somebody told me that the answers were wrong. I think that those here, 17 over 80, exactly is negative 17 over 80. You're correct, it's negative 17 over 80. Okay, and this is the work for today. I try to do a review of all the 6th grade, that basic 6th grade ideas using mathematics. I hope that it helps you, this video. I hope that it works a lot for you, and this helps you in your studies for mathematics of 6th grade. I'm going to stop, but before stopping, telling you that I hope that you enjoyed this video. I hope that you like the video, and see you in another's. Bye bye. Enjoy your day. I hope that everything was clear. Bye. See you. See you, everybody.